going to show you how to use the Harris Oxy Acetylene kit. Harris has a range of kits, each designed for a particular customer's requirement. There's the contractor's kit, the professional kit, the standard or classic kit, and it's this kit we'll be using today.
The classic kit has an 801 oxygen regulator, 801 acetylene regulator, a 632 handle, 883 flash guards, a 732 cutting attachment, an E43 mixer, 23A905 welding tip, and a 62901 AC cutting tip.
Now let's run through the items in the kit, explaining the various features and benefits. Firstly, we have the 801 acetylene regulator. It's designed to give you the correct flow even when the cylinder pressure gets low. It's easy to adjust, has large, easy to read gauges. The proven seat design is supported by a stainless steel spring and a stainless steel pin, and this gives you the ultimate in reliability. The Model 801 Oxy regulator has all the benefits previously mentioned in the acetylene regulator, plus it's manufactured to withstand the high cylinder pressure of oxygen. Remember, a regulator is a pressure vessel. The Harris quality ensures you get the best in safety. Both regulators have built-in burst relief devices for increased safety. The handle comes complete with flash guards, and they're a safety item to stop mixed gases going up either hose. It comes with stainless steel ball valves, and they're designed to improve flame accuracy and smooth adjustment. It comes with a brass handle for a long life. It comes with a fuel gas valve underneath, and that's designed in case of emergency, you can get to it. Doesn't matter left or right hand, you can always get to the fuel gas valve, and that's a safety benefit for the operator.
Harris has re-engineered the fitment so that the O-rings fit into a tapered joint, ensuring a safe seal.
It also means it's quick and easy to change attachments.
It's also where you have your hand.
This is the mixer. It allows the fitting of the copper swage welding tip, ideal for silver soldering, brazing, welding and small heating jobs. And it's designed to give you a very good flame shape. Combine that with the mixer and precise mixing and you'll find the jobs a lot easier for the operator. Here we have the cutting attachment. Notice the solid brass head, the solid body, designed to give you a long life and toughness. Notice the solid lever folds out of the road when you're using that cutting tip. It's a heating tip. The cutting valve has an ease-on built into it, so when you're piercing or starting a cut, you're not getting covered in sparks, and that makes the operator's job a lot easier and a lot safer. It features 3 stainless steel tubes, keeping the heat away from the O-rings and where our operator has his hands. This also increases the toughness of the unit, as the 3 tubes are very strong. It also keeps the cutting oxygen away from the mixing chamber, and that keeps the purity of the cutting oxygen and makes cutting a lot easier.
The mixing chamber is in the head of the torch and is a large area, which ensures accurate mixing of the gases. It operates on the positive pressure mixing principle, but importantly, because of the large chamber, a much lower pressure, 35 kPa, is all that is needed.
Many units on the market operate on a much higher pressure, 100 kPa in a fuel gas line. With the Harris system, you work on a lower pressure. That means a lower cylinder pressure, and you save on gas.
Finally, let's look at the cutting tip. It's a 2-piece item. Simply pull it apart to clean it. If the seat gets damaged, you can repair it yourself. Just rub it on some wet and dry sandpaper. Typically, tapered seating tips are thrown away when the seating surface is damaged.
The value of being able to reseat the tip yourself is a real benefit. The other thing we do with the Harris tips, we make a precise flame shape, which gives you hot, quick starts, and you'll see that in the demonstrations later. Before we progress to the demonstrations, let me explain to you how Oxy Acetylene process works. The mixed gases at the flame are supplied in approximately equal ratios by the torch, but the combustion burning process needs more oxygen. Where does it get it from? It gets it from the surrounding atmosphere, and that eats up into the flame. Now what happens is, if you get into tight corners, the process can become unstable as the oxygen is used up. You need a precise, accurate mixing system. Harris engineers understand that point, and they put the mixing system in the torch, and that gives you an extra benefits in safety and performance.
Now on to the demonstrations. Turn on the acetylene regulator. Set it to the required pressure. Just refer to the manual. Turn on the oxygen regulator and once again set the required pressure. Make sure all connections are tight and do not leak. Connect the welding mixer complete with tip. Before lighting, make sure you purge. This clears the system of mixed gases. Note that the flash guards are a big help in keeping the integrity of the system. Turn the acetylene valve on. You only need a little. Light the gas. Turn it on more till the black smoke disappears. Then back off till you get a little black smoke. This is about right. Now turn on the oxygen. Notice we start off with a carburizing flame with a long feather, and it is reducing to a neutral flame with the feather just gone. Any more and the flame will become an oxidizing flame, a short, harsh, loud flame. Note this type of flame is unstable and more prone to flashback. The demo here is oxygen acetylene fusion welding of mild steel. Note the angles of the tip and torch. We first develop a molten pool, then add filler metal. Once you master this technique, you're ready to do any welding job. You get the feel. Practice is the key. Oxygen acetylene are the only common industrial gases that can fusion weld mild steel. Brazing and silver soldering are similar, but you're not bringing the parent metal temperature up to a liquid state. Dull red would be a good description. Now let's move on to cutting.
It's a neutral flame that's needed 99% of the time, but a common trap for operators is when they're cutting a thick piece of steel is to turn their oxygen up, which gives an oxidizing flame, which becomes a safety and performance issue. A flat seating tip has a great advantage when you're changing it. It doesn't need to be tightened with a 10-pound hammer or a big shifter. It's easy to undo and it's easy to tighten. Another suggestion came up from an operator was in that we build into the cutting valve, in the fact that it's got a lot of travel in it. It's a bit like a variable speed drill. You decide how much cutting oxygen you want to bring in. You bring in a little or bring in a lot, it's your choice. There's a lot of travel in the cutting valve, making it a lot easier for the operator to use. As mentioned previously, the real difference is in the mixing accuracy and the flame shape. Get these two areas right and the whole thing is a lot easier and a lot quicker to use. It's a little bit like a carburetor of a car. Get the mixing right and the jets right and the whole car feels totally different. The rev heads out there will know what I mean. We're after a neutral flame, same as we had before, and that'll make it a lot safer and give us the right performance.
Watch how quickly we heat up the edge. That's the Harris difference. The tight flame pattern, superior flame shape, and because we keep the cutting oxygen pure, away from the mixing chamber, we get fast cutting, time after time.
Here we are, ready to gouge just by changing the tip.
Once again, see how quick we punch the heat in. But the thing to remember is that oxygen acetylene uses up the surrounding oxygen. Heat rising from the job can deflect away the atmosphere, which contains oxygen. That's why sometimes you need to adopt an in-out technique. Notice it's quick and you develop a feel. This could need to be more pronounced in tight areas, for example a T-joint or a U-joint. The speed and quality is governed by the same factors as cutting, flame shape and oxygen purity.
Heating is another application often used today for bending steel, undoing a seized nut, those types of things. We're going to now show you heating.
Set your pressure as per the manual, but the important element is to keep the pressure as close to equal as possible. Increasing the oxygen pressure beyond the acetylene pressure can lead to an oxidizing flame, which we know is unstable. The common trap is operators set it at the same position on the gauge. For example, 2 o'clock could be 150 kPa on the acetylene gauge. The same position for oxygen will be 1000 kPa. The amount of heat you develop is governed by how much gas you burn. Using small bore 5mm hose seriously limits performance and greatly increases the risk of a severe flashback. Notice we are using twin 8mm hose for a 60% increase in flow. When you light the flame, it's the same principle. Neutral is the desired option. Watch the actual heating technique. We hold the tip close. Flame's about 3mm off the plate to start with. As the metal gets hot, deflecting heat up, we lift, tip and rotate, ensuring the surrounding atmosphere can get at the flame and complete the combustion process. Acetylene should not be drawn from the cylinder quicker than the filling time. That is 1 cubic metre per hour. For example, a G-size cylinder should last 7 hours of heating.
In this video we've shown you Oxy Acetylene welding, brazing, the cutting process, the gouging process and Oxy Acetylene heating. We believe if you use it the Harris way, you're going to get superior performance, gas savings and a much safer system. In the tips and the tape, the instruction manual, you're going to maximise the performance out of your tool. That's it for now. Thanks for your time. Bye.